Bismillahirrahmanirrahim. Assalamu alaikum. My name is Muhammad Asim. I'm working as DevOps engineer. In this video, I'm going to show you how to use AWS Load Balancer Controller. Guys, this is very important video if you are a Kubernetes user or if you are using the AWS EKS, which is the Kubernetes service. So in this video, I will be covering a lot, and believe me, this video is going to help you. So in past, a lot of people looking for um, application load balancer ingress with multiple namespaces. So in past, what happens that if you use the different namespaces, you have to spin up application load balancer ingress for each namespace. So in this video, I'm going to show you now with the application load balancer controller, you don't have to spin up multiple application load balancer ingresses. It is going to save your cost a lot because I'm going to show you the hands-on demo that if you use the multiple namespaces or different namespaces, you have to use the single load balancer controller ingress. And I'm going to cover that, and also I'm going to cover in this video the Fargate Profiles, which is the serverless you can use in AWS EKS. So let's begin. So this is the demo we are covering. So let me give you an idea what we are going to spin up, and I'm going to spin up all automatically with a single command. Let me show you guys. So first of all, I'm going to open my terminal, and I will be using Ubuntu 20. Okay, so this is Windows subsystem for Linux, and what I will be doing, I will be navigating to this directory. So I'm currently in this directory, and I'm going to open this in VS Code. So guys, this is the Terraform code through which I'm going to spin up my VPC, and this is the stuff with regard to the application, sorry, with regard to the RDS and secret manager, but this is not going to be the part of our video. So I'm using my previous Terraform module. So I will be covering this later, but this in this video our focus is that I'm going to spin up one VPC, and in that particular VPC I'm going to spin up my EKS cluster, and this is our EKS cluster with the version 1.19, and that in that particular EKS cluster I'm going to spin up application load balancer ingress, and it is going to be the single load balancer which is going to route the traffic to different namespaces. So for that, I've also written a script, load balancer controller, and I will be using Helm. So for this demo, or prerequisite of this demo is that you should have Helm install, kubectl install in your machine, EKSCTL install, and Terraform. So everything is installed in my machine. So what I'm going to do, I'm going to first of all navigate into my environment and dev. So I will be providing all this code to you guys, and let me spin up all the stuff with the single command. So what I'm going to spin up, first of all, as I told you, I will be using um, custom VPC, and in that custom VPC I will be using EKSCTL. How I'm going to spin up that particular EKS cluster in that through this output. The output of this, let me show you. The output of this is going to be the input for that EKS cluster, and I will be showing you every step with regard to the deployment. So this is the single command, guys. If you, I will provide you the link of this code, and if you use with your hand, you will be in a good position to understand the code as well. So I'm going to use this command, terraform apply dash dash auto dash approve, and I'm going to use, let's have a let's have debugging as well of this, so you will see everything is in there. So I'm going to use this as well, bash uvx, and I'm going to use this load balancer controller. So all will be in a single command. When I use this, it is going to ask me for the RDS password, which I will be providing, and this is going to be the password of the secret manager. But this is not the part of this demo, so I'm going to provide a simple password to my RDS. So it is gonna spin up all the infrastructure that I am looking for in a single command. Then I will be covering the apps section, and in those particular apps section I will show you in a bit. In those particular apps section I will show you how you can use the different namespaces for and use a single application load balancer to route the traffic to those particular um, namespaces. And also we are going to um, use our Fargate profiles. So guys, this will take about at least 30 minutes. So till then I'm going to pause the video, but I will be showing uh, before that I want to show you guys the code with regard to the application. So as I told you, this is our target. This is the single ALB ingress with different namespaces plus Fargate profiles. So this is our task today. So first of all, what I will be doing that I will be using this Fargate profile YAML, and I will be using my cluster name. So the cluster I'm using, uh, I will be using, and it is going to spin up in a few moments. And the name of that cluster is going to be Cloud Geeks -CA-EKS. So this is the cluster, and the Fargate profile name is going to be Cloud Geeks-app2. And I'm going to use the same namespace. You can use different namespace of your choice as well. So I'm, for the ease of use and my understanding, that I will be using the same namespace with my application. I mean with the Fargate profile. So anyway, this is the creation of Fargate profile, and the command which are required to use with those um, Fargate Fargate profile creation is EKSCTL get Fargate profile. This EKSCTL create Fargate profile, and if you want to delete, you can delete the Fargate profile as well. This is through I mean EKSCTL CLI, and this is the first part. And let me show you and the UI as well. And if I navigate to the Elastic Kubernetes, okay, go to the ECS. From there I will be navigating to EKS. So this is the EKS cluster. Currently we don't have any cluster. So once the cluster is going to be available, you will see that in the configuration section of that particular cluster, you will see in the UI of that Fargate profile. So we will be doing everything from the command line EKCTL. So I already told you the prerequisites that you should have installed. So let me have one session and that particular machine, and let me show you that what I have here. So I have EKCTL install. I have let me show you the versions as well. So I'm using the latest version of EKCTL, and Terraform is definitely, I guess, outdated. So Terraform version. So this is the Terraform version I'm using. So I'm just showing you the prerequisites that you should have. I have kubectl installed, Terraform, EKS. Um, so I guess that's it as far as the EKS management is concerned. Okay. So you see currently our database is spinning. So let me show you that our VPC in which we are going to spin up our EKS cluster. I always choose to use, custom VPC to spin up my EKS clusters. So and this give me leverage that I will have my custom tags and the security of VPC is according to my requirement. So this is the VPC that we will be using. So uh, so as far as the RDS is concerned, it is also spinning up, and also it is going to use the secret manager. But this that part is going to be the future videos. So this is the VPC we are using, and till then I have to wait for about 30 minutes, but let me also cover the theory part as well, which I will be not covering later on. So this Fargate profiles, I've already told you that this is the first thing we will be creating. And if I navigate to my apps section, there are three apps with different namespaces. So app 1 is with the default namespace, app 2 is going to be the Fargate profile, and I will be using the namespace Cloud Geeks app 2, and app 3 is going to be in the namespace Cloud Geeks CA. So guys, these are three different namespaces, and for all these three different namespaces, and I will be using the single load balancer, which is the application ingress load balancer. So let me first of all open this one. So let me open this deployment plus service. So I've just put all the stuff here. So this is the basic echo container from I will be pulling from the GCR. So what it does is simply echoing the stuff with regard to the EC2 instance or node group on which the machine on which this pod is spinning up, and also it will show the um, IP address of end user as well. Okay, so this is pretty much about this container. Okay, so if I navigate to my application 2, so I have three files here. So namespace YAML, as I told you, I'm using different namespace here, and this is the namespace Cloud Geeks dash app 2 I will be creating here in app 2. So this is the deployment and service .yaml. So what I will be doing here, I will be creating this one deployment, and along with that deployment, I will be creating one service as well. And this is the image I will be pulling from my sample, Docker Hub repository where I put this image. It is publicly available, and the path is going to be this slash green slash index.html. So for Fargate profile or Fargate, the requirement that you should have IP, and IP is great in a way that application load balancer is going to send direct traffic to your pod. So any traffic coming to your load balancer is going to be directly um, sent toward your pod instead of instances, because there are a lot more hops involved in that, and um, that is a great feature by this load balancer controller, that it give you an IP so you can interact with your pod directly rather than um, covering the different hops of EC2 instance and all other stuff. So guys, this is with regard to the deployment and service. And if I navigate to ALB Ingress, so this is the Ingress part I will be covering here in all three applications. So this is the one single annotation which is now I will be using for a single load balancer controller, or for my application load balancer controller. What I will be doing that um, I will be using this annotation ALB Ingress Kubernetes IO group name. So group name is Cloud Geek CA. So every application is going to be part of this group name, which means that I'm going to use the single load balancer, and every namespace is going to be part of this group. So if I navigate to this ingress, you will be seeing that this is the group name I'm using here. So in excuse me, in third application, I will be using the same annotation, and this annotation is the same. So you can definitely choose your own, but make sure that this annotation must be persistent if you want a single if you want to use the single application load balancer. So that is it, you have to use. So even in case of instance, for instance, I will be using this um I mean, in this application number one, I will be using instance. So you can choose to have IP address as well. So this part is done, I guess. Further in ALB Ingress, I will be using the HTTPS. So I will be updating this ARN of this application. So I will be able to redirect to um, HTTPS. So what I will be doing that I will be using this domain which is associated with the former off spinner legend Saklan Mushtaq. So I'm also working part-time with him as well. So I will be using this domain. This is Saklan Mushtaq Cricket Academy, and what I will be using this app 2.saklanmushtaq.com, app1.saklanmushtaq.com. So I will be updating the record in the DNS in Cloudflare. So this is the Cloudflare. Let me show you this. This is the Cloudflare stuff. So this is his website. If you wanna scroll through, you can use that. So anyway, this is with regard to the domain I will be using. So I need to show you that you will be seeing that this is the app to Saklan Mushtaq. I've updated here, and even in the ingress in application one, I will be using app1.saklanmushtaq.com. So for application load application app1, I will be using my etc host entry. Because of that, I have set up, this is not with https, so you see no ARN, but this is going to be with the ARN. So this tutorial is in a way cover most of the stuff, how you can set up the http and how you can set up the https as well. So this is with regard to the host name and redirection rules. So use annotation. I will be using annotation above. You see redirection is there, SSL settings, and SSL redirection is here. So anyway, this is something with regard to the HTTP and HTTPS setting. So this is the second one. So what I will be doing, I will be simply updating this ARN. So I'm going to simply copy this, and I will be navigating to my section of ACM certificate manager. Okay, so I will be generating certificate for this domain, because if I will be not provide if I'm not provide this genuine ARN, it spits out an error, and HTTP is not going to work properly. So everything star.saklanmushtaq.com. So click next. DNS verification. Okay. 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 So um, it will give me the, if I refresh, it will give me the CNAME, which I will be putting in my DNS record. So I will be copying and pause the video. I will show you the DNS entries as well. Let me pause the video and I will be back with you guys. So guys, what I've done, I put the CNAME record here. After a few moments, this pending validation is going to be updated. Till then, what I'm going to do, I'm going to simply update this ARN of this ACM. Okay, so if I navigate to this section, I'm going to simply replace this with the one which is provided. So I'm going to save this, and okay, this part is done with regard to the HTTPS setting, and I will be showing you the application load balancer as well, the rules I will be showing which are going to be updated automatically. One thing, the issue with regard to the target group automatic registration is not working, might be a bug, I don't know why. So anyway, I will be showing you that as well. So anyway, that is not a big issue, but as I told you, what I've done, I've used the same application in app one, but I've set up a different namespace. I put it the same application in different namespace to show you guys that how application load balancer is single application load balancer is going to route the traffic to different namespaces. So in past it is not possible, and it is a requested tutorial. Lots of people ask me that you should create a tutorial that the issue we are looking for, that we have to spin up a multiple load balancer for different namespaces, and it is costly. For instance, in a single load balancer, if you have 3 or 4 application in a single EKS cluster, and you're using definitely this different namespace, you have to spin up 3 to 4 cluster, I mean 4 namespaces, 4 different application load balancer. So this is not the case. I'm covering everything which you should be aware of, and it is the latest deployment we are using, in a way that lots of people I saw using the legacy old architecture of EKS, where they are not using the managed nodes. So I highly recommend to use the managed nodes, and the latest feature EKS providing, the Fargate profiles, I'm covering that as well. So everything is covering here. So if I navigate to this section, if I refresh, you see this is issued to saklanmushtaq.com, the domain I've showed you. So anyway, with this is with regard to the domain, and now I'm going to show you the stuff with regard to um, the application load balancer. Okay, so okay, secret manager. Okay, let me pause that. I will be back you in a moment. So guys, issue was the disconnectivity of my internet. Anyway, that RDS is already spin up. I've already tested, my code before I do. So this is not part of our demo. So along with that, just need to show you, if you are interested in a code, that you should have RDS along with the secret manager as well. So this cover that as well. So if I navigate to this secret manager, you will be show, I will show you that this RDS is gonna spin up with that same credential I provided, and it is used custom CMK uh, key of KMS. So if I navigate to this section, so it is using my KMS key, at rest this KMS is going to be encrypted by this customer CMK. So I'm going to retrieve that, and this retrieval is done with via the that particular customer KMS key which is created. So this is the same password I showed you in the start of this demo. If you are interested in setting up all this in automated way, this is the way to do it. And let me show you the KMS stuff as well. So this is something which might be you need. I mean, this can be part of your production ready environment. So that is why I'm also covering this as well. Although my intentions was to just show you that stuff. So currently, guys, this EKS cluster is spinning up. It is taking the output, the private subnets, the public subnets from that Terraform output, and that output is injected into this EKS CLI, and it is spinning up that particular EKS cluster in that custom VPC. So you see our subnet IDs are automatically populated. This is the private subnet IDs, and these are the public subnet IDs. So I don't have to do it manually. Everything is, I'm using with the single command, and it is going to deploy your infrastructure with a single command. So this is the key alias Qasim I've created. Okay, so he's my brother, younger brother. Okay, so anyway, let me show you the cluster side as well. So if I navigate to the EKS cluster, I simply refresh it. You will see that CloudGeek CA EKS cluster is started spinning up. And if I navigate to the configuration section and navigate to the compute, you will be seeing in a few moments. If you read this side, you see this cluster does not have any nodes. Note that nodes that are not part of Amazon EKS managed node are not shown in this AWS console. So you will be seeing that we are going to use the managed nodes. You see, if you navigate to the EKS script I've created, so um, I will be using this managed switch, or you can say that managed part of this EKS cluster. So um, and I will be creating EKS Fargate profile from the EKS CTL. So this will take about at least 10 minutes to spin up the cluster. So guys, this is with regard to the infrastructure, that how easily you can spin up the whole massive infrastructure, which includes the custom VPC, and that in that custom VPC you can spin up the EKS uh, cluster according to your needs, and it is going to be managed, highly available. Along with that, the advantage of managed node is that you don't have to have at least administrative burden of patching, OS patching, and all that stuff is going to be um, totally not your concern. That all stuff is going to be all stuff gonna be done from the AWS side, so you don't have to worry all that. So this is how easily you can spin up the infrastructure. If you watch my video till end, you will, and also go through the code as well. So I'm providing you the production ready stuff that you should be able to use this latest modern code to spin up your infrastructure. And the best way and highly recommended way to manage your Kubernetes EKS Elastic Kubernetes service is through the EKS CTL. So these are my recommendations. So as I told you that, let me show you the part of Helm as well. So okay, I forget to tell you the Helm as well. So Helm uh, dash dash short, I think short version. Okay, let me copy the command from this. I forgot the command. And okay, if I navigate to the load balancer controller, this is the Helm version dash short. So simply I'm going to for this, and I will be showing you what we are doing in Helm. So this is the version. So as it is currently correctly showing that uh, Kubernetes cluster is configuration file is not readable because our cluster is not yet spin up, but this is the version of Helm we are using here. So I forgot to tell you that previously I was showing you the stuff with regard to the um, packages you should have in your machine. So this is the Helm as well. I missed out. So okay, regarding this Helm script, so this is the documentation. If you want to go through the documentation and the GitHub, I've actually I provided you all the important links. You should be able, you must read if you want to go in depth what is there, because it is not possible for me to cover all the stuff in one single video. But I am providing the code, I am providing you the documentation, important links. You just have to simply cover this and comment this. How can I improve as my side as well? So anyway, in this script, what I'm doing, I'm providing the cluster name. So this is my cluster name. The region is this. VPC ID is gonna fetch up from this automatically. This is the regex I set up for Ubuntu 20 LTS. So I'm using this Windows subsystem for Linux. So you see, so I'm using Ubuntu 2004. So I can use the git bash as well, because on Windows I've also installed these packages, Helm, um, and all these packages which I've already discussed. So for Windows, the regex is if you want to use the git bash, the regex is different. Regular expression is going to be for chopping up your VPC ID is little different, so I have provided that as well. So it's gonna automatically add this repo and install this load balancer controller in our EKS cluster. So once cluster is available, I will be showing you this pod is going to be available. So it is going to be available in a while. Till then, I'm going to pause the video. So as far as the theory of this video or the infrastructure we are creating, the scripts we are using, I've already shown you what we are covering here. So in the last section, I will be covering let me just simply remove all the stuff. So in last section I will be covering this single ALB with different namespaces and Fargate profiles. So this is the apps section. I need to show you that final part. So till then I'm going to, I should pause the video because it will take at least 5 minutes more. So guys, our EKS cluster is spin up. Now the script is doing, or that command is doing, is running that particular script. And in that particular script, I shown you that projects. So it is going to automatically, you see, use this VPC ID. So I've used the bash debug mode. So that's why you're able to see what is happening inside that particular bash script. So it is now installing the load balancer controller. So guys, this is the load balancer controller. This is not the application load balancer ingress. So we will be spinning up the application load balancer from the annotation. So let me show you that kubectl get nodes hyphen -wide. So you will be seeing that now we will be able to see our nodes which are now available. And if I show you kubectl get pods -a, it will show all the pods along with that application load balancer controller. So we spin up automatically, I mean, the all infrastructure with a single command. So this is how easy it is. So anyway, this is the load balancer controller. So this video is cover that part as well, the automatic creation of uh, application load balancer as well. So we done that. Okay, so if I navigate to the UI, so you will be seeing that two nodes are going to be available. If I simply refresh it, you will see that worker group, which is the managed node. So we have two nodes, and if I click here, you will see more detail with that capacity type, minimum node, maximum node. This is for auto scaling, uh, where you can set up the cap as well for you should that you should not exceed maximum node from 2 as well. So this is with regard to the detail of those managed node. Let me navigate to the EC2 section as well. So what I will be now covering, the main part of our demo. So these are the two nodes available along with the key. Anyway, if you don't want to use the SSH, you can simply avoid that as well. So anyway, everything is now available. So now I'm covering. You can create, Fargate profile from the UI as well. But as I told you, I will be covering from the CLI. So now I'm in this part. So uh, this is the last part. So first of all, I'm going to create a one Fargate profile. So I've provided you all the commands. So as I you already seen that we don't have any Fargate profile, so I'm going to create one Fargate profile, and I'm going to copy this command. So if I uh, simply navigate, let me show you that. Let me navigate to the desktop and simply navigate to Terraform. I am in this directory. This is single ALB. Okay. So if I navigate to the apps, if I navigate to the Fargate uh, directory, this is the directory I am in. So I'm going to provide the code, and these are the commands .txt. I've already opened this file. So I'm going to simply trigger this file with this command. So I've copied this file. I'm going to trigger it. So I'm going to create a Fargate profile from the EKS CTL, which is the CLI. So if I navigate to the UI section, so you see currently we don't have any Fargate profile. If I refresh it, you will shortly see one profile is going to be available. So currently it is in pending state. So it is going to deploy that particular stack. So what EKCTL does that it spin up the cloud formation stack for you. So let me navigate to the cloud formation stack as well. So I'm going to show you that as well. So this is the backend. So you see this is the Fargate profile stack creation. Cloud formation stack is completed. So if I navigate to the UI section of that, simply close it, we don't need it, and I simply refresh it, you will see one Fargate profile. Cloud Geeks app 2 is in creation state, and it is going to be available in a few moments. So that part is going to be with the creation of Fargate profile, and simply with the creation of application we are going to use the simple three commands. So I've already covered the theory what we are going to achieve with this. So I will be now I'm going to simply open one another shell, and let me navigate to the desktop, and in that desktop I have a Terraform directory, and in single ALB. So if I navigate to the apps section, you see three applications are available. So I've already covered all parts with regard to the theory. So I'm going to straight away simply apply this first application. So what it does, it is gonna spin up the application load balancer, and that particular single application load balancer we are going to use for our all application navigations. So if I navigate to the EC2 section, you will be seeing that one load balancer is going to be in provisioning state. So this is the one which we have created in, and if I navigate to the target group, you will be seeing one target group. So as far as with the target groups, as I told you that auto registration is not happening. So uh, I don't know, is this a bug or whatever? I have to do it manually. Anyway, let's see this time. Because previously I have tested all this stuff, so it was not working fine. I mean, as far as the automatic registration of nodes in target groups are not happening. So anyway, this is provisioning, and if I navigate to my second section, you see Fargate profile creation is almost um, in ending state. And if I navigate to the EKS Fargate profile, if I refresh it, so in UI it is going to show it is active, and also it is going to be available active here as I mean done. This CLI is going to be end up here in a few moments. So anyway, once this done, I'm going to simply use my command for the app2. So this is the app2. It is going to create the Fargate uh, nodes on that particular Fargate profile. What Fargate nodes are, that it is going to spin up those tiny nodes, and those tiny nodes it is going to spin up your application. And for that it is necessary that if I navigate to the application section, you should define just like in ECS, and that how much CPU and RAM you need. So that is why I have resources requested memory 128 MI, CPU 500 millicore. So these are the resources, and also I've limited these resources to that particular um, I mean uh, to that particular level. So this is very important. You should have knowledge of this, as if you are using Fargate profiles. And if I navigate to this section, it is almost in completion, in complete state. So you see, it is done now. So what I'm gonna do, I'm gonna use the command for my app2, and it is gonna use the same application load balancer and different namespace. Let me show you the namespaces. kubectl get namespaces. You will see that we have now two namespaces. One default, in that particular default, we have spin up this application with this is now active, and you see if you navigate to the target groups, you see one application is with regard to the targets but no target registers. Okay, let I will fix this. So this is with regard to our pods. So target are going to be automatically available here in this Fargate profiles. So in Fargate profiles, I will be using this CloudGeek CA app, and default is the one I've already shown you. So if I do kubectl get nodes hyphen o wide, you will see that nodes with IP are going to be provisioned in a few moments. So by default, you will see the two nodes which is are the default node. These are the by default nodes. So it spin up two nodes as well. Why two nodes? Because in our deployment section, the replicas we are requested are two. So that is why it spin up two nodes, and in that particular nodes, it's gonna spin up your application. So if I do kubectl get pods -a. I'm going to show you the namespaces as well now. So if you see kubectl get pods, you will see that this is the default namespace on our for our echo server. Okay, and this is the Cloud Geeks application 2 with the two requested um, applications or replicas. So that is why it spins up two Fargate nodes. So it is very important that you should define the resources. So it is going to, very effective for your billing perspective as well. So now I'm going to spin up my uh, third one. So where am I? Let me. I don't know where am I. Okay. Okay, I'm in the right place. kubectl apply -f, and if I use this third um directory, which is going to spin up my third application in a different namespace. So, and it is going to use this namespace, and it is going to use that particular load balancer. So kubectl get pods -a. So, guys, you see, this is the Cloud Geek CA, and I have just requested for one replica here. So, it is now running, and these are the two others. So now, what I'm gonna do, I'm gonna simply navigate to this UI, and if I simply refresh it, you see these two IP addresses are the same. Let me show you that 49, 46, 57, 52. So these are the IP addresses, Fargate IP addresses of those nodes which it spins up. So it is automatically coming up here. If I navigate to the other two target groups, if you see the targets, it is not actually showing any targets. And if I navigate to the other targets, all the pods are spinning and everything is there. So if I do kubectl get ingress, you will see three ingresses. kubectl get ingress -a. So you will see three ingress in different namespaces. So this is the default namespace, and this is the Cloud Geeks CA namespace, and this is the Cloud Geeks -app2 namespace. But the application load balancer is a single application load balancer, and I'm going to show you the listener rule as well. But what I'm going to do, I'm going to simply okay, these are with the IP addresses. I'm going to simply add these targets to, I'm going to manually register these targets. So these targets are now registered, and previously, I mean, automatically these are not registering. So I don't know, it is a bug or something, or I might be miss anything in the annotation. Please update me if I miss anything. So anyway, I have to do it manually, and you will be seeing that these targets are going to be automatically in healthy state once initialized. So currently it is in the initializing state. So you see these are healthy, and it is going to be um, healthy as well. So once is done, so everything is working fine. So what I will be doing, I will be updating my let me show you the first of all the listener rules as well, so you will have a better idea. As I told you, I'm using the Cloudflare flare, so redirection is there, but I'm using the HTTP part as well. So how I'm going to achieve this HTTP app? So I'm going to simply achieve this part. I mean, from the normal Cloudflare DNS entry, and it is going to redirect to HTTPS, and I will be showing that by updating the ALB into that particular DNS. So let me show you this part as well. So this is the one. If the path is /green index /index.html and the host is app2.saklanmushtaq.com, redirect this to HTTPS. So it is using that ACM. So you see, it is only in this HTTPS. So as I told you, I'm covering the HTTP and HTTPS section as well. So what I will be doing now, I will be simply updating my DNS with this DNS name. So let me pause the video and I will be back with you guys. So guys, I have updated the DNS, endpoint of this DNS. So propagation will take a little time, but let's try. First of all, app2.saklanmushtaq.com, and it is going to be path green index.html. So it might be coming from cache, but I have to simply refresh it. So it seems that it is updated. So this is actually coming from that particular proper DNS, but application 1 and 2 are not going to come from this DNS. Why? As I told you that I'm using the redirection, and if you see the rules in that particular DNS are only covering the HTTP part. So if HTTP request to app 3, it should be coming to that, because this is the port 80 HTTP, and app1 is going to be this one. So how I can achieve this? I can achieve this through the etc host entry, and what I will be doing, I will be simply doing the ns lookup, or simply ping this uh, load balancer IP and test it. So I'm using the ns lookup. I'm going to copy this, and simply if I navigate to this notepad, run this as administrator, as I'm using the Windows. So I'm going to update my etc host file. So I'm going to simply update this. So I'm going to simply update the IP. So app1 and app3 are going to be available. So as app1 and app3 are going to be using that echo server, so simply let me copy the IP address, and okay, that's fine. And if I simply open this in incognito mode, so the request is going to that particular load balancer, and you see it is also forwarding these X forwarded headers. It is, which means that it is showing my IP as well. So if I navigate to the app3 as well, so it is gonna show me that echo server as well. So as I told you, all these are in different namespaces coming from single load balancer, and app2 is this one. So everything is working fine. What I'm going to do, before I'm going to simply show you that I'm going to remove this app1, and you will see that this application is going to remove that from this particular single load balancer, which is provisioned for all three uh, different namespaces, and these are the different namespaces, in fact already shown above. These are the different namespaces for the applications. So I guess you have an idea. I've also covered the Fargate profiles as well. I'm going to provide you the code as well. Anything left? Yeah. What I'm going to do, I'm going to I'm going to delete this application. So simply I'm going to kubectl delete hyphen f, and I'm going to delete this application. So this prompt is going to pause at this end, because it has a dependency, but it is going to be removed from that particular application load balancer, and other application are not going to be affected. So let me show you that part as well. So but some of the stuff I have to do manually. So this is pretty much this application is pretty much deleted. So if I do control C here, let me show you that part as well. So if I navigate to my app 1, if I refresh it, you will be seeing nothing. If I simply refresh it, you see app 3 is working fine and app 2 is working fine. So app 3 is deleted. So as far as the removal of this target group, you will see that target group is going to be available there. So if I navigate to this target group, you see okay, it is healthy, which means that it is the one which is working, so which is regard to the application 3. And if I navigate to this section, okay, you see it is now unused, so I have to get rid of this target group manually. It is not removed. So if I delete this, you will be seeing that remaining two target groups with two different namespaces with single load balancer is going to be working fine. So you see this application is now gone and traffic is not coming to this. So the traffic is coming to this application 3 and coming to this application HTTPS setup. So anyway, guys, this is the tutorial. If you like the video, please like, share and subscribe. This is the Ramzan special, I should say, I've made for you guys. Please like, share, and subscribe again. And have a nice day and happy Ramzan. And Ramzan Mubarak to all of you. Thank you very much. Have a nice day. Assalamu alaikum.